In this lesson, we shall focus on Mathematics 1B, Math 141, Tutorial 9. We shall look at polar coordinates. 9, sketch the following polar curves. In each case, state the values of theta for which R is, in Roman figure 1, a maximum, 2, a minimum, Roman figure 3, 0. Now, the couple of things we need to do to sketch this, we need to first and foremost focus on the table that we use. So we need to draw a table. Right, now drawing the table will highlight certain things. At this point, we can even put the table here. Or maybe here, it's okay. Right, so if you put it there, you'd have to look at theta and then R. Let's start with theta, that is 0. And then we have pi over 4 radians. And then we also have pi over 2 radians, moving in steps of pi over 4 radians. That's pi over 4, then pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. 4 pi over 4, pi. 5 pi over 4. 6 pi over 4. 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2 pi radians. Right, with this mentioned, we are able to have this particular table here. But if we can draw this table and be in a position to make sense of it, so now we have 0, we have pi over 4 radians, we have pi over 2 radians, 3 pi over 4 radians, pi, 5 pi over 4 radians, 3 pi over 2 radians, 7 pi over 4 radians, 2 pi. Right, so that is sort of what we can sketch. Then we have the following. So now, okay, we are dealing with this one. R equals 3 in brackets 1 minus sine theta. So if you put 0, the sign of 0, 0 giving us 3. Putting pi over 4, then you're going to have 3 minus, or 3 in brackets 1 minus sine theta. So you can use a calculator for this one, because it's going to involve some decimals. And then you have 3 in brackets, 1 minus the sine of 45 degrees, which is pi over 4. And this is 0.88. So we have 0.88. But if you put pi over 2, the sign of pi over 2 is a 1. 1 minus 1 is 0. Meaning when I have a 0 here, putting the 3 pi over 4 would put the sign in the second quadrant, in which the sign is positive. So it's going to be the same as 0.88. But now the sign of pi over 2 is going to be, the sign of pi is going to be 0. So it's going to be 1 minus 0. It's a 1. 3 by 1 becomes exactly 3. Now the 5 pi over 4 is an angle that is in a different quadrant. So you're going to have 3 in brackets 1 minus the trigonometric sine of the 5 pi over 4. So you can say 5 times 45 degrees. 5.12. 5.12. 3 pi over 2. Now, the sine of 3 pi over 2 is a minus 1. Minus minus is plus. 1 plus 1 is 2. 3 by 2 it's a 6. Let's delete 7 pi over 4 radians. 7 pi over 4 radians. Right, dealing with 7 pi over 4, what you're going to have is you're going to have 3 in brackets 1 minus the trigonometric sine of 7 pi over 4, which is 7 pi 45 degrees. And 7 pi 45 degrees is going to give us exactly 5.12. Right, 5.12. Okay, now last we look at the 2 pi. The sine of 2 pi is 0, and 1 minus 0, it's a 1. 3 by 1 is exactly 3. So obviously this is going to be an x, and that is going to be a y, like this. Now let us analyze the table and see what we can do out of it. But most importantly, there are a couple of things we need to take into account. But first, we're dealing with 0, pi over 2, pi, 3 pi over 2 radians. But also, this is a full revolution of 2 pi radians. Now we have pi over 4. Pi over 4 is an angle that is somewhere here, midway between 0 and pi over 2 radians. Now at pi over 4, okay, first at 0, we have range 3. We have 3. So this one is an r theta point. So you have that r is 3 and theta is 0. Here, r is 0.88. R is 0.88. And theta is pi over 4. So you have this and this. Okay, now at pi over 2, then you have 0. You have r is 0, and then you have pi over 2. That is the point. That is exactly the point. So you're going to have this one. Okay, yeah, this one we possibly did last time, but we're just doing it to make sure that we spend time on the polar graphs. Now, we're going to have exactly the fact that this one, you start here, and then you move to this. Now, 3 pi over 4 is this one. It's 0.88. So you'd have 0.88 together with 3 pi over 4 radians. So now, we also have at pi, you have 3. So you have this. So now, you have 5 pi over 4. 5 pi over 4 is somewhere here. So now if 5 pi over 4 is somewhere here, you have r theta. Okay. So r is 5.12 and theta is 5 pi over 4. So now 5.12 is somewhere here. So you have 5.12 and then that is r, and then theta is 5 pi over 4. 5 pi over 4. Three pi over 2. 3 pi over 2 is going to give us 6. It's going to be here. There's going to also be a 7 pi over 4 midway here. And then the symmetry, because same magnitude, 5.12, and then 7 pi over 4 regions, like so. So now that is going to be exactly this point. 2 pi regions is going to be this point. So this is exactly the shape that has been given on the side for the polar coordinate curves. Okay, we saw this last time, but obviously we are sort of making more sense of it. Let us look at the next polar graph. Okay, but we're not done yet. So sketch the following polar graphs. In each case, state the values of theta for which r is a maximum. So for theta equals 3 pi over 2, r equals 6 is a maximum. That is the first Roman figure. The second Roman figure for theta equals, you see, that was 3 pi over 2 maximum, then minimum. Minimum is the smallest one, and you can see the smallest one is actually exactly 0. And so for theta equals pi over 2 radians, r equals 0 is a minimum. So for theta, okay, yeah, the values of theta for which r is minimum, right? So the minimum value of r, the smallest one amongst the three, the 0.8, is 0. But also, when you look at, we need to state the values of theta for which r is 0. For theta equals pi over 2 radians, we can see that r equals 0. R equals 0. And at pi over 2 is it's where we have 0 only. Okay, and the table testifies that as well. Okay, right. We look at the next question. Let us look at part B. Let us look at part B. Let us look at part B. Right, in part B, we have exactly the following. We have precisely the following. Okay, let us look at this given shape. Now, this shape here, oh, I wanted to mention something else. Okay, that's fine. I'm going to mention some of these things. But let us look at part B. Now, Part B is a very interesting one. Let us look at the sketch of it. Let us look at the sketch of it. Let us look at the sketch of it. So you'd have the following. So you'd have like theta and then r. Okay, so you start from 0 radians. And right now you have a couple of values that, so I want to sketch the B. Now the B obviously has a couple of things that are very important, but because it's gonna have half, there's one half here. So we might use the value of theta for which half is gonna appear. So we can take pi over 3, and then 2 pi over 3, and then 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 2 pi radians. Now, let us deal with this. So when you have cosine at 0, like cosine 0 is 1, half minus 1 is minus 1 half. At 3 pi over 2, cosine 3 pi over 2, which is cosine 60 degrees, is 1 half. 1 half minus 1 half gives us a 0. 2 pi over 3, 120 degrees, is minus 1 half. So you have half minus 1 half giving us a 1. Pi, cosine pi is minus 1, giving us 3 over 2. Well, pi over 3. Okay, so that would be um okay, so now you have 4 times 60 degrees, 4 pi over 3. So that's going to be exactly a 1. 5 pi over 3, which is 0.5 minus cosine of 5 times 60, which is 0. The 2 pi is going to be 1, and then cosine 2 pi is 1, and then if you say 1 half minus 1, and then it's going to be minus 1 half. Okay, let us analyze these together. So we're going to have the following shape. Right, and then you have y and x. And then now, okay, you analyze this. Right, so you'd have exactly the following thing. You'd have exactly the following thing. You'd have precisely the following thing. Right. So, right. So you then say, okay, we're continuing with that. Right. Right. So we continue. We continue. We continue. We continue. Right. So we pause to reason this out, and we want to actually focus on this and see how well we can be able to deal with these particular kinds of questions. Okay, so this kind of shape, okay, this kind of shape has a specific name, and we call it, we said last time, and we're going to say it again, we call it a cardioid. Call it a cardioid. Right, we call it a cardioid. We call it a cardioid. Now, because it looks like a heart. So cardiovascular, so with heart, vessels. So that's a heart, cardio, heart. Right, so we actually now going to be looking at this one. And this one is also a very, very interesting shape that we need to learn. But also let us look at how we sketch this one first and foremost. Right, we focus on the sketching part of it. We focus on the sketching part of it, okay? So, at zero, zero is this one. So you have 0, pi over 2, 3 pi over 2, no, pi, and then 3 pi over 2. Right, so you have 3 pi over 2, and then 2 pi radians. Now, we continue. Right, so now let us focus on the following. We focus on the following shapes. Right, this shape has a specific name. It is called a limacon. It is called a lima. It's called a limacon. It's called the limacon with inner loop. With inner loop. So it is called the Limacon with inner loop. We start, okay, at 0. 0 is this one. You have minus pi over 2. So if you're at 0, you move in the opposite direction. But 0.5 units, so you're at 0, then you move in the opposite direction, and then you have minus 1 1/2. At now you go on to this one, which is pi over 3. At pi over 3, then you're going to have a 0. So you are actually there. At 2 pi over 3, this one, 120. You have a 2 pi over 3 ray. You have 1 unit. You have 1 unit. At pi radians, we have 3 pi out of 2. At pi radians, so pi is this one, and obviously at this point, if exactly at pi, you measure 3 pi over 2 radians. I want us to look at this very carefully. Let us mark off this way. Right, if at pi we have 3 3 over 2, but obviously here it's negative numbers, so you're going to have minus 3 out of 2. Okay, and then at 4 pi over 3, okay, yup. 4 pi over 3 is going to be 1 unit. So this is 4 pi over 3, but it's going to give us like 1 unit. And this 1 unit is symmetric. It's the same as this. So there is 1 unit here, and there's also 1 unit there. Okay. So let us continue. Okay, we did 4 pi over 3, and then there's 5 pi over 3, which is this one. 5 pi over 3, it's going to be 0. We have 0 here, we have 0 there. Okay, so they're just at the origin. And then at 2 pi is this one. You have also negative 1/2, which is back to this here. Right, looking at this, you can see that you need a little bit more points. You need a little bit more points. Like here we missed what happens at pi over 2. For instance, at pi over 2, you have what? At cosine pi over 2, this is 0, giving us 1/2 theta r. So here at pi over 2, you have 1/2. So here, so and then at 3 pi over 2, you have 1/2. Okay. So with theta r, 3 pi over 2, and then there's also 1/2. All right. All right, so we continue. Now, you have these shapes. But looking at these, you're able to see that you're going to have this one, for example, connecting the points. This here, this and that, this and that. Right, so that is what we are able to see. But now you need to examine what's going to happen in some other parts of the curves, like what is going to happen between this one. So you might need a pi over 6 here. So here, to see what is happening, take what is in the middle, pi over 6. Okay, an angle of pi over 6 in magnitude, but yeah, you take a pi over 6, but if you have 2 pi over 6, 3 pi over 6, like this. Okay, so you can, okay, let us have that one. So you're going to have 1/2 Right, so you can do 0.5 minus cosine of pi over 6, which is minus 0.3. Okay. So if you actually going to take pi over 6, so you have to include those intermediate points. At pi over 6, then you're going to have minus 0.3. So at pi over 6, then it's going to go in the opposite, which is, this is 0.5, which is minus 0.3. So you're going to have theta r. We included pi over 2. We included 3 pi over 2. And it was 1/2, 1/2. We included pi over 6, which is minus 0.3. And also, if you include, okay, yeah, because pi over 6, 2 pi over 6, 3 pi over 6, yeah, 3 pi over 6 is going to be the same as pi over 2 radians. So this one it's going to coincide with exactly the main thing. Right, but you can take other angles there. Like if this one is 60, then we should take an angle that is between 60 and 90, just to see exactly what's happening there. But then this is going to be there. So you're going to have this, because the cosine is an even function. So you're going to observe symmetry here. So you're going to have this, but you're also going to have this. Now exactly you actually would have the following. So what happens in some parts of these, like between 90 and 60 degrees and 90 degrees, what angle do you put there? 80 degrees. So if you're going to do 80 degrees, not a special angle, so you're going to do 0.5 minus cosine of 80 degrees, which is 0.32. Okay, this is 0.5, but this one at 80 degrees is going to be 0.3, so somewhere short here. And this one is going to come back to 0. But we need another angle that is going to be, we need another angle that's going to be, for example, here between 3 pi over 2 and the 5 pi over 3. 5 pi over 3 is 5 by 60. Okay, so this is 300 degrees. So which is, yeah, this is 300 degrees. And then this is 270 degrees. So there is, between this one, it's, you can take 15 degrees, 15 degrees. Because between 270 and 300 is 30. So what you can do is, yeah, take 285 degrees, for example. So you're going to do 0.5 minus the cosine, 285. 285, which is 0.24. 0.24. Okay, if this is 0.5 and then you have 0.2. 0.24, that is R, and the theta is, we've taken 285 degrees. Okay, so it's going to be exactly this one. So with this, five pi over 3. 5 pi over 3. Okay. What do they have 5 pi over 3? 5 pi over 3 became 0. Became 0. But if this is 300 degrees, then you can take an angle that is between 300 and this one is 360 degrees. So you can take like 330. Can take 330. Yeah, 330 degrees in the middle here. 330 degrees. 0.5 minus the cosine of 330 degrees. Minus 0.36. Minus 0.34. So at 330, obviously, it's going to take you to an opposite, the back of this line. The back of this line, so it's going to give you a point that's somewhere there. Right, so, and moreover, looking for other points, like between 285 and 300 degrees. You know, you can take 290. Take 290 or 298 degrees. Right, so you have 0.5 cosine 298 degrees, yeah? 0.03. So you can see that as you're approaching the 300 degrees, this will become 0. Would become 0. Right, so this is the shape, but this is called a Limacon with inner loop. Inner loop. Okay, let's look at the next question. Okay, but there are other questions you can answer, like the values of theta for which R is a maximum. So what are the values of theta whenever R is a maximum? So when theta, so we're looking for the maximum. Theta equals what? All right, so whenever theta equals something, you have maximum. And what would that maximum be? You can see that whenever theta equals pi radians, R3 over 2 is the maximum. R3 over 2 is the maximum. Now we are looking for the minimum. Whenever theta equals 0, for example, or 2 pi, r equals -1/2 is the minimum. It is the minimum. Right, it is the minimum. Continue. 0. Whenever theta, whenever theta whenever theta equals, when do we have 0? Yeah, like at pi/3, like whenever theta is pi/3, theta is 5 pi/3. R is 0. So that is when R is 0 for the third Roman figure. In the Limacon with inner loop, that is the shape. We move on to the next question. Right. Okay. Yeah. Right. So, okay. Right now, we look at the next one. C. C. Okay, now, right, right. We have the following. Okay, let's deal with, let's do C. So to do C, you're going to have the following. You're going to have R theta, 0. So now, okay, I want us to look at C, so we're going to do it here. Right, so we're going to actually do it here. Now in part C, you're going to have, so you're going to have the following. Okay, theta then R. Theta then R. Theta is 0. Theta is 0. Okay, and then now we're gonna have a look at the angles that are involved here and see how best we can have this. We can include as many angles as possible. So at this point, we need to include our 0. And because of the square root of 3, it's going to be at the zeros, like at 0, and this one at pi. This one at pi/2, it's going to be exactly that. 3 pi/2 2. This is going to be minus 2, which is going to actually be that way. So now we are just brainstorming and thinking about the angles to include. Let us take 0 and we include, for instance, pi over 4 is going to be here, but you can include pi over 6, 30 degrees. Pi over 6, 2 pi over 6. 2 pi over 6 is pi over 3. 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. Now 8 pi over 6 is 4 pi over 3. 9 pi over 6. 3 pi over 2. That is 9 pi over 6. 10 pi over 6. 10 pi over 6. 11 pi on 6. 12 pi over 6. It's 2 pi. So we have here the following. We have the following. It's 0. Sine 0 is 0. And then square root of 3 plus 2 times 0 is the square root of 3. At pi over 6, square root of 3 plus 1, or 1 plus square root of 3. The sine of 30 degrees is 1/2. 1/2 times 2 is 1 plus the square root of 3. At pi over 6, it's the square root of 3 out of 2. The sine of 60 degrees, which is the square pi over 3, square root of 3 out of 2, and then this one is square root of 3, square root of 3, which is 2 the square root of 3. Pi over 2, the sine of pi over 2 becomes 0, rather 1. 1, and this is 2 plus the square root of 3. 2 pi out of 3 which is square root of 3 2 times the sine of 2 times 60. 2 times 60 degrees. Okay, so that's going to be 2 the square root of 3. 5 pi out of 6. Okay. So the sine five by 30. Okay, so that is 1 plus the square root of 3. The sine of pi, 0. Square root of 3. 7 pi out of 6, which is square root of 3 plus 2 times the sine of 7 times 30. Okay, which is minus 1 plus the square root of 3. But minus 1 plus the square root of 3 is the same as what? 0.73. 0.73. So here you have minus 1 plus the square root of 3, which is 0.73. Now I'm going to do 4 pi out of 3. Okay, let's check this one. So you have the square root of 3 plus 2 times the sine of 4 pi out of 3. 4 pi out of 3 is like 4 pi 60. Okay, so yes, 4 pi 60 degrees. The yard, which is 0. 3 pi over 2, so dealing with the sine of 3 pi over 2 is minus 1. Square root of 3 minus 2. Square root of 3 minus 2, which is minus 0.27. Minus 0.27. Okay, now dealing with 10 pi out of 6, which is 5 pi out of 3. 5 pi out of 3. So which means that you'd have the square root of 3 plus 2 times the sine of 5 by 60, which is 0. 11 pi out of 6. Is the square root of 3 plus 2 times the sine of 11 by 30. 11 by 30 degrees. Minus 1 plus the square root of 3. But you already know minus 1 plus the square root of 3 is 0.73. 2 pi, the sine of 2 pi becomes a 0, and therefore that becomes only the square root of 3. Let us discuss the sketching process. Y, x, 0, pi over 2 radians, pi, 3 pi over 2 radians, and then 2 pi radians. Okay. So now let us take a look at these and make sense of this. Now let us see what we can do Starting with 0, for example. At 0, you have the square root of 3. At pi over 6, we have 1 plus the square root of 3. So if this is the pi over 6 ray, you'll have more in length. This is square root of 3, but this is going to be, square root of 3 plus 1. Then you have the next one, which is pi out of 3. Okay, so with this one, which is 2 to the square root of 3. Pi over 2, it is like 2 plus the square root of 3. All right, 2 plus the square root of 3 at pi over 2. And then now, 2 pi over 3, 2 pi over 3, it is actually exactly 2 to the square root of 3. At 5 pi over 6, we're here. 5 pi over 6, it is 1 plus the square root of 1 plus the square root of 3. 1 plus the square root of 3. This one is at pi, you have the square root of 3, but the numbers are negative here. So it's going to be negative the square root of 3 at 7 pi out of 6. Point 0.03. 0.03. So you have this one, 0.03. That's going to be 0.073, excuse. At 4 pi out of 3, it's going to be 0. So you're doing 4 pi out of 3, but it's going to be at 0. 3 pi out of 2. It's going to be minus 0.27, like minus 0.3. Okay. So that is going to be exactly there. So at the 3 pi over 2, then it's going to be somewhere here. That's going to go in the negative. And you have the square root of 3 minus 2. At 5 pi over 3, yeah, which is close to, is this one here? You have a 0. So this one is going to produce a 0. At 11 pi over 6. Okay. 11 pi over 6. So which is 0.73. This one is going to be 0.73 on it. And then at 2 pi, it's going to be exactly the square root of 3 there. Let us see what we've got. We start slowly from the origin. At 0, we have the square root of 3. At pi over 6, we have 1 plus the square root of 3. Pi over 3, 2 the square root of 3. Pi over 2, 2 plus the square root of 3. 5 pi over 6, right, so you have this one. Okay, pi over 2, then you have, which is pi over 6, yeah, which is 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 4 pi over 6. Is this one? Which is exactly at 2 to the square root of 3. 5 pi over 6. Somewhere here. Pi is going to be the square root of 3, but put it somewhere there. Just to make sure the diagram looks a bit neat. So you're going to have the square root of 3 here. It's 7 pi out of 6. We have 0.73. Okay, and then 4 pi over 3 is 0. Three pi over 2 3 pi over 2, then you have this one. It's exactly this one here. At 5 pi over 3, you also have a 0. 11 pi out of 6, you have point that. And 4 pi out of 3, okay? Because the 4 pi out of 3, let's see, the square root of 3 plus 2 times 4 times 60. Right, so that would give us a 0. So you then would have that, but you need more angles, because at pi over 6, we had exactly that. So it need more angles, like an angle between pi over 3 and an angle between 60 degrees and 90. Like 60 and 90. You have 270, like 75, excuse. So you'd have square root of 3 plus 2 times the sine of, right, so you're going to have 75 degrees. Which is going to be like a 3.66. So now the 3.66, if this one is about 0.27, so the 3.66 will be approximately somewhere here. Okay. So we analyze some of the angles, like if you take an angle that is between these two, take an angle between this one, 7 by 30. 210. So if this was like 210 degrees and this one is 4 by 60, 240. Between 210 and 240, the difference is 30. Take 15 of those, like 225. Check that. So you'd have square root of 3 plus 2 times the sine of 225. Square root of 3 minus square root of 2. 0.3. 0.3. So indeed it's going to be is 0.3 here at 225, which is going to give an angle that is obviously there. Right, taking some angles that are between, for instance, this one is 5 by 60, 300 degrees. And then now this one is 11 by 30, which is 330. Okay, so if this one is 330 and this one is 300 degrees between them, 315. Square root of 3 plus 2 times the sine of 315. Which is 0.3 still. Now you examine even more angles. Even more angles, like the angle between 270 and 300. You take 285. Okay, so you have 285. So which is the square root of 3 plus 2 times the sine of 285. Good. So you can see that at 285 we have minus 0.2. 285 degrees, we have minus 0.2. Minus 0.2, it's going to be here, making these like this. The bisymmetry in the first and the second quadrant of the sine is positive in both. So you're going to have this, because the sine is symmetrical about the, it is positive in both quadrants. The sine is positive in both quadrants by the cast diagram. by the cast diagram, so the sign is positive in both. Right, so this is it. So this is the shape that we have got. This shape here has a specific name. And the name associated with this shape is that of a Limacon with loop. That of a Limacon with loop. Right, is the shape of what we term a Limacon. Limacon with loop. Okay. Limacon with loop. Limacon with loop. Okay, let's continue. Right, after having sketched this here, okay, there are a couple of things obviously you need to take into account, like your maximum, minimum, and zero values. Right, for instance, for which values of theta? When theta is equal to 0 degrees, okay, when is it maximum? Right, the maximum would have to potentially be the biggest one, and I would imagine that if you compare 2 plus the square root of 3 with 2 times the square root of 3. Okay, so you're going to have 2 plus the square root of 3. And that is 3.7. It's 3.7. 2 times the square root of 3. 2 times the square root of 3. Which is 3.5. This one is 3.5. So you can see that the maximum is going to be 3.7. So whenever theta is pi over 2, you have that r is 2 plus the square root of 3, and this is the maximum. But simultaneously, what you're able to get becomes the fact that, okay, so it becomes the fact that, okay, also I want to mention something else. I want to mention something else. That here you need to switch the signs, okay, because it is square root of 3 minus 2, but it's minus 0.7, so you need to take the negative of that because the numbers are positive there, giving it the sign 2 minus square root of 3 because that becomes a positive number. Because at 3 pi over 2, you have the negative. So you move in the opposite direction. In terms of magnitude, you'll be here, but the sign of the number is the opposite because the numbers are positive there, giving that loop there, the 2 minus the square root of 3. Moreover, the minimum, theta, the minimum, which one is it? So the minimum is going to become, let's look at the table and the graph. Right, it's the least one. Is it, can it be 0? Okay, there are places where it is 0, but also R can be, it's like at pi, it's also -3, at pi is the square root of 3. So we're able to see, therefore, that R would have its negative value, which is minus 0.27 whenever we are at 3 pi over 2. So which means, therefore, whenever theta is 3 pi over 2, R is the square root of 3 minus 2, which is minus 0.27, which gives us the value of R that is very small, very small. Right, because then the rest aren't so small. Looking at the table, are not so small. But when is it 0? At 4 pi over 3. Whenever theta is 4 pi over 3, R becomes 0. R becomes 0. R becomes 0. Right, R becomes 0. Right, R becomes 0. Okay. We continue with our analysis of this. That is what we are actually able to observe. That is what we are able to observe there. Right. Let's move on to the next question. D. All right, so let us look at D. Let us look at D. Right, we take a look at D. Right, we take a look at D. Okay, we're gonna sketch it, but we think about it first. We try to make sense of it and make sure we have the relevant thought about it. With the relevant thought about it. With the relevant thought about it. Okay, we continue to analyze part D. But looking at part D, because it has 2 theta, we can think about the angle that's going to work. We can think about the angle that is going to help us in this case. Right. Okay, so let us ponder to reason this out. D. Let us draw some table and have some values and see what values are going to be missing and fill in the gaps where necessary. So we're going to have theta together with R, 0 we start with. And then we have at 0, okay. Let's do pi over 4 in C. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. At 0, it's 0. At pi over 4, then you put pi over 4 here, which is 2 times pi over 4, which is pi over 2. The sign of pi over 2 is a 1, giving us 2. If you put pi over 2 here, 2 times pi over 2 is pi. The sign of pi, 0. 3 pi over 4, which is 3 pi over 2. The sign of 3 pi over 2 is a minus 1, so it's going to be minus 2. Here, the sign of 2 pi is 0. 5 pi over 2. Check this with the calculator to make sure you get the correct answer. So if you're doing 2 times the sine of 2 times 5 times 45, because the 5 pi over 4 is like 5 times 45 degrees. 2. Okay, but if you put 3 pi over 2 here, then the 2 is going to cancel, giving out the sign of 3 pi is 0. So we continue. Now go to 7 pi over 4. Okay, in which case if we need to use a calculator, need to use a calculator. Right. Need to use a calculator. So we continue with our analysis. We continue with our analysis and we check what we have. Right. Right. Okay. Let's deal with 7 pi over 4 regions. Okay, yeah, we're gonna let's just use a calculator to save time. Right, so we're gonna have, for instance, like 2 times the sine, 2 times 7 times 45, which is minus 2. So now 2 times 2 pi is 4 pi, 0. So we have this, and then we have also that. So there's 0, pi over 2, pi, 3 pi over 2, 2 pi radians. Let's see what we're going to get here. At 0, you have 0. At pi over 4, we have 2. At pi over 2, 0. Okay, so we need some more angles here. Like, we need another angle to put in the middle here. Pi over 8. So let's see what we're going to get with that one. So then you're going to have 2 times the sine of 2 times pi over 8. is 180 degrees divided by 8. Something like so. Giving us exactly the square root of 2, but the square root of 2 is 1.4. Okay, this gives us exactly the square root of 2, which is 1.4. Right, so we have this. Okay, so now, if you're going to take pi of 8, 2 pi of 8, 3 pi of 8. Somewhere here. And then now, that's what you're going to use. Going to use 3 pi of 8. 2 times the sine of 2 times 3 times pi out of 8. Yeah. So you close. Which is still the same thing. The square root of 2, which is approximately 1.4. So you're going to have this. Let's use a red color. This. So now we're going to go to this is up to pi over 2, then we have 3 pi over 4. The 3 pi over 4. The 3 pi over 4, then you're going to have what? Let's check. Um, right, it's going to be -2, but because it's minus, then you must move in the opposite direction. Right, you must move in the opposite direction by 2 units. So you're going to be here. So this one of us is going to give us -2. At pi, then you have 0. And then you would need some intermediate values like this, like here and there. So like we've seen, it's 3 pi of 8, like pi of 8, 2 pi of 8, 3 pi of 8, 4 pi of 8, 5 pi of 8, 6 pi of 8, 7 pi of 8. Okay, the pi of 8 is just to divide this one by 2 to get in the middle. So let us look at 5 pi out of 6. 5 pi out of 8, excuse. Zits. Okay, pi of 8, 2 pi of 8, 3 pi of 8, 4 pi of 8, 5 pi of 8, 6 pi of 8, 7 pi of 8, yeah? 5 pi of 8. Use a calculator. Which is 2, the sine of 2 times 5 times 180 divided by 8, which is minus the square root of 2. Okay, so this is going to give us minus the square root of 2. Minus the square root of 2, it means that it's going to go to the square root of 2 here. In the same way, you have 7. Let's look at 2 times the sine. Okay, then you have 7 pi out of 8. 180 divided by 8, which is minus the square root of 2. Okay. Uh-huh. So this one is going to be minus the square root of 2. That was what we got. So if this one is minus square root of 2, then it's going to be here. Give one square root of 2 and then 0. So it's going to be this shape. Right, so you have this. Uh-huh. Now let us see. You're going to continue here. Right, after pi, there's going to be 5 pi out of 4, which is 2. And then you're going to need some other angles here. So this one is 5 pi out of 4. 7 pi out of 8, 8 pi out of 8, 9 pi out of 8, 10 pi out of 8, 11 pi out of 8. Okay. So to the sine of 2 times 9 times 180 divided by 8. Take a look. Square root of 2. So this is going to be the square root of 2. Square root of 2 is 1.4. 11 pi out of 8. Two times 11 times 180 divided by 8. Square root of 2. So you have square root of 2, square root of 2, square root of 2. There. Okay, and then now we have this. Let us continue with this part. So now we're going to go beyond. There's 3 pi over 2, which is going to be 0. And then there's this one is going to be like 7 pi over 4. It's going to be minus 2, so it's going to be here. 2 in the opposite. 2 in the opposite. And then now we're going to have to take, if this is 7 pi out of 4, then can I do it? Because 11 pi out of 8, 12 pi out of 8, 13 pi out of 8, 14 pi out of 8, 15 pi out of 8, and then 16 pi out of 8, which is 2 pi. So you come and then say you need two times the sine of 2 times 5 times 180 divided by 8 minus the square root of 2. So this one is going to be having minus square root of 2, but minus square root of 2 is going to be square root of 2 in the opposite. But also, if you deal with this one, 5 pi, and then this one, 13. Do 13, which is now the 13 pi of 8 is going to be minus the square root of 2, which is going to be a square root of 2 in the opposite, meaning that you're going to have exactly this here. You're going to have exactly this, like this, like this. Okay. So now there are a couple of things like what is the maximum? The maximum R occurs when theta is pi over 2, for example. It's one of the angles. And then R will be 2. And 2 is sort of the maximum. Okay, so this is the maximum. So 2 is the maximum. But whenever theta becomes pi, R is 0. 0 for Roman figure 3. Roman figure 2. Theta equals pi over 2. Okay. Theta equals, yeah. Okay. We're interested in the minimum. Is negative 2. Okay. The smallest one is negative 2. And that happens when theta is like 3 pi over 2, then you have 3 pi over 4, then you have R is minus 2, for example. So think about it. Make sure you actually can interpret that. Make sure you can actually interpret that. Right, 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 right. We continue. We continue. Right, 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 right. Okay. Any question? Any question? So now you think about this and make sure you sort of have an understanding of this. Make sure you have an understanding of these. Make sure you have an understanding of these here. Very, very interesting. Right, 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 right. Make sure you have an understanding of this shape. Right, right. So we continue. We continue. We continue. We continue. Right. We actually continue analyzing this. So you think about the shape and make sure that you can be able to interpret this particular shape, and you can be able to make sense of it. You can be able to make sense of it. Right, so obviously this is some rose curve. The name of this is a rose curve. Okay, the name of that is a rose curve. So y'all think about it. Make sure you're able to understand it. And you can be able to make sense of it very, very well. Okay, there are a couple of things that are important. What things remain important? What things remain important? So, what things remain important? Okay, um, let us look at E right now. We'll look at E. Now, E is very, very important for us. It is the cosine of 3 theta. Take a look. But because of the 3 theta, we might think, okay, we move in what step? Okay, obviously this very subjective. You can see from time to time we adjust the step, you know. But now sometimes the step would be 2 pi divided by 4 times the coefficient, at least. This would give us some step. And then now this is 2 cancels and then it's pi out of 6. Suggesting that we can take pi out of 6. Because whenever r is cosine b theta, or r is the sine of b theta, we can do the step 2 pi divided by 4b. Obviously, 4 times the modulus of b. Right, so that is sort of a strategy we use. 4 times the modulus of b. Four times the modulus of b. Four times the modulus of b. Four times the modulus of b. Okay, I want us to reason this out. And make sense of this. Right, and make sense of these. In the sense of what happens here, let us draw some table. When need be, we shall adjust the step like we have done before. And then now we have this. Can even take pi of 12, if that is the meaning, if that is necessary. Okay, we take a look at this one. So you have this. Theta r 0. Okay, so now you have pi out of 6. And then if you move pi out of 6, you add to pi out of 6 to pi out of 6, you get 2 pi out of 6, which is pi out of 3, 3 pi out of 6. 3 pi out of 6 is pi out of 2, 4 pi out of 6, which is 2 pi out of 3, 5 pi out of 6, 6 pi out of 6. 6 pi out of 6, 7 pi out of 6, 8 pi out of 6, 4 pi out of 6, 8 pi out of 6, 9 pi out of 6, 10 pi out of 6, 10 pi out of 6, 11 pi out of 6, 12 pi out of 6. Okay, let us fill in the table. Now we're going to start. Cosine 0, 1. This one is going to be 3 pi out of 6, which is 3 times pi out of 6, which is 3 pi out of 2. 3 pi out of 2. Cosine pi out of 2 is 0. And then this one is minus 1. 0. 1. Okay, 5 pi out of 3. Okay, gonna use a calculator. 5 pi out of 3. 5 times 60. Yeah, 1/2. 0.5. 3 pi is minus 1. 7 pi out of 3. Cosine 7 pi out of 3. Okay, so gonna be 7/180 divided by 3. So, which is 1 1. Okay, then you have cosine 11 pi of 6. 180 divided by 2. 180 divided by 2. Mhm. Divided by 2, excuse. Divided by 2, 0. So now you have 15 times 180. 15 times 180 divided by 2. 15 times 180 divided by 2, 0. 9. Cosine. 9 times 180 divided by 2. 9 times 180 divided by 2. 0. Okay, let's sketch. Okay. So now you have xy 0 pi over 2 radians, pi 3 pi over 2 radians, 2 pi radians. So we continue. So now, for example, it exactly the following. It exactly the following. At 0, you have a 1. At pi over 6, okay, let's put a ray for pi over 6. At pi over 6, you have 0. At pi over 3, 60 degrees. So now, at pi over 3, you have a -1, but -1 is going to be here, making it a positive 1. At pi over 2, it's 0. It's, okay, 2 pi over 3. . at 1. 5 pi over 6. We have half. Pi. At pi is minus 1, but it's going to be this one. 7 pi over 6 is this one. 7 pi over 6, you have 1/2. Because it's positive, we're going to just put it here. 4 pi over 3. It's a 1. Okay, so this is 3 pi over 3. This looks like a 4 pi over 3, which gives a 1. And then there is 3 pi over 2. Which is a 0. Okay. Right. And then now you'd need, okay, this pi over 2. Let's see what we've done here, because we're moving in steps of pi over 6. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. So that is 5 pi over 3. So this must be a 3. These must be a 3. And then we're going to do 3 times 5 pi is minus 1. And then 11 pi over 6 is going to be like this and that, yeah? 5 pi over 3. So it's going to be 3 pi over 2, then 5 pi over 3. This is going to be minus 1, which goes here, opposite. 11 pi over 6. So 11 pi over 6 becomes a 0. 2 pi becomes a 1. Okay, we got these, but they are just not enough. Because we have this one, that, and that. These are our main maximum points. Yet, we do not have the other points in the middle. So we need to find some points in the middle. So we're going to do pi of 12. So we're going to do this. We need to divide this one by 2, getting 12. So pi out of 12. So pi out of 4. The square root of 12 of 2. Okay, you put pi out of 12 here. And then it becomes pi out of 12. And then obviously when you do this one, it becomes 3 pi out of 12. But 3 pi out of 12 becomes cosine pi out of 4. Cosine pi out of 4 is square root of 2 out of 2, which is 1 over the square root of 2. 1 over the square root of t. Right. 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 So we continue. Right. So we're going to have, yeah. Yeah. So 1 over the square root of 2 is a decimal. But what kind of a decimal? It's point something. You can check with the calculator. If you do cosine of 3 times pi out of 12, pi is like 180. Out of 12 is 180 divided by 12. Did you close? Okay, it is that one which is 0.7. So this one is going to be 0.7. But the cosine is positive in this quadrant there. So it's part of 12, and then you have 2 pi out of 12, and then you have 3 pi out of 12. 3 pi out of 12 is pi out of 4. Cosine 3 pi out of 4. Cosine 3 pi out of 4. You check with the calculator. Okay, so you do 3 pi out of 4. Cosine 3 pi is 180 out of 4, which is minus. So at 3 pi, at pi out of 4, it becomes 3 pi out of 4, which becomes a negative. See, which becomes a negative. So in other words, this one is going to be, this one is at 0.7. Okay, so let us do this. Okay, it's going to be a 0.7, 1, and then let us do 11 pi out of 12. So if you're going to do 11 pi out of 12, okay, 3 times 11 pi out of 12. Okay, so which is 11 pi out of 4. Yeah, let's put the 12 because we've put the 3, which is minus. So it's going to be actually exactly a minus. So this one is going to come and be somewhere there. Going to come and be somewhere there. So, and hence this will close this way. Right, by symmetry, this one is going to be 1 and it will close like this. There's one also here. That's going to be one, and it will close like this. That's sort of the shape that we have here. That's the shape that we have here. But obviously, you can see the step that works very well here is pi out of 12. If one does pi out of 12, then you shall be able to get a perfect shape. Shall have like many points, and shall have a longer table, and you can get a very accurate shape. So if this is the step. But now we answer the questions in terms of the maximum and the minimum. Like the minimum is going to be, the minimum is r equals -1 when theta is pi out of 3. The maximum is 1 when we have 0. The r equals 0 when theta is pi out of 2. Okay. I think that we have done something. I know that these are not a lot, but it's something we've done. So we shall return then and check what to do next. We'll have to return and see what to do next here. Because, yeah, we then need to think and plan for the next start. So let me see. Okay, today we're going to have several sessions. We're going to have a session, this session we've had now. We're going to have another one we can have another one at 4. If you're going to be free at that time. If not at 4, at 6. Those 2 times. 4 or 6. And then we shall discuss the other time. But yeah, 4 or 6 is up to you. But I'm giving you those times. Then you think about them, then because we have done up to E, and then when we've done up to E now, yeah, then we're going to be starting with 10. Okay, looking at the dimpled, Limacon, etc. Okay, but you can see they take a bit of time, these curves. And obviously you can have more strategies to sketch them. Yeah, but they take a bit more time to do. But yeah, you can continue at 4 and do more. And then the physics also, I'm sure, will be done. We shall do some physics today. So shall discuss some physics to see. Shall see the time for the physics. Yeah, we're gonna discuss it when we meet at 4, and then we can schedule the time for physics. Okay, but we're gonna make this recording available. So yeah, and then we're gonna meet at 4 or 6, depending on when you are free, and then we can continue with these questions. But also we can do other things. I mean, it's not all about sketching these. In the end, we know how to sketch these, but you just need to practice more sketches, and then spend time on the what? On the conics as well, directrix and other things. We shall spend time on the conic sections in the afternoon. Okay, because we can just jump in, because you see some of the things are very similar. Like we'll go through these 10 and sketch these ones. Okay, we'll sketch them. Okay, like this r squared, we'll sketch them. After having sketched this r squared, there are lots of them. There are lots of them. So, but excuse me, we shall sketch all this, and then we can jump, because these are like 6 in one, number one. And then we can also do the areas. We can do 3 areas, so that we can like touch every question, every section. Because now we can't just know only how to sketch these polar graphs. What about other things? We need to also learn other things. So that is what we're going to do in the afternoon. We shall jump, do 10, but like part. We do like 2 here, polar curves, 2 or 3, the areas, the conic sections, sure that will make a difference. To make sure we get to reach every part, so that I don't know only one section. Now, that is very important. I think for now, Umar, thank you for joining us until 4. Yeah, until 4. We shall send the recording. But yeah, but take care, take a break, and return at 4. Right. Goodbye for now. Right. Goodbye for now. Goodbye.